For this lesson, I'd like to talk about the multiplication principle, and again, using this to solve a linear equation. So just like with the addition principle, we're starting with two things that are equal, a and b, and we're stating that if you multiply both sides by the same number, you still get two things that are equal. And the same holds true for if you were to divide both sides by the same number. That is, if we divide both sides by, let's say, c, you would still have that the left side is equal to the right side. Here we're going to assume that c is not equal to 0 because you can't divide by 0. So as I write down here, you can use this idea to solve linear equations of this form. And so I've put a couple of those in example 1. One where we have 1/5 x is equal to negative 12, and the other where it's just 5x is equal to negative 12. So let's start with this one on the left. 1/5 x is equal to negative 12. If you want to get x by itself, you have to cancel 1/5. So your job is to choose a number that you're going to multiply to both sides to cancel 1/5. The number that works is 5, or I'll write 5/1. If you multiply that to the left side, 5/1 times 1/5 cancels to give you 1. But according to this principle, you also have to do this to the right side too. So that's 5/1 times, and this is negative 12/1. I'll use some parentheses. So here's what's going on. I saw the 1/5, and I thought multiply by 5. This 5 and this 5 cancel. And you could write 1x if you want to, but that's just the same thing as saying x. On the right side of this equation, you have negative, and 5 times 12 is 60. So here it is. The solution is negative 60. And you can even check to see that this is true. You could put negative 60 in place of x and see if the left side is equal to the right side. Now, for this second equation, we have 5x is equal to negative 12. If you want to solve this one for x, you want to cancel 5. I'm going to divide both sides by 5. So I'll start with 5x is equal to negative 12. And I'm going to divide the left by 5 and divide the right by 5. I've done the same thing to both sides of this equation. In doing so, this 5 and this 5 cancel to give you just 1s. So I'll write this as x. And on the right side, I have a negative 12/5. And that can't be reduced. That's just, I'll leave it alone as an improper fraction, but that's the solution to this second equation. So obviously we're going to get two different solutions because they were different equations, but the idea is if you have something like a 5th and you want to cancel it, multiply by its reciprocal, 5. Whereas if you have 5 and you want to cancel it, you would divide by 5, or said another way, multiply by 1/5. And that's how this principle works. So let's try this principle again here in example 2. I have negative x is equal to 28 minus 104. All right, so to solve this one for x, the issue is it's not just x by itself. There's a negative in front of it, so we're going to have to do something about that. But I'm going to start by simplifying the right-hand side. What is 28 minus 104? If you take that difference, it's definitely a negative number. So I'll just copy down the left, and the right is going to be negative 76. So the equation definitely looks a lot simpler. But now, what do we do to both sides of this equation to cancel x? There's a couple of different ways you could write this, but here's what I'm going to do. I'm going to divide both sides by negative 1. Maybe I'll even put a 1 in front of the x here, just for emphasis. So it doesn't matter what number is in front of x. It could be a fraction, it could be a decimal, it could be positive, it could be negative. If there is -1 in front of the x and you want to cancel it, you have to divide by that very same number. In doing so, they completely cancel and leave you with just x. Now, on the right side, it's a little bit different. You have -76 divided by -1. So 1 goes into 76, well, you just get 76, and a negative divided by a negative is positive. And that means the answer is x is equal to positive 76. And for the last example, just one that's combining several of these ideas together. So here we have -1/2 x minus x is equal to 4. The goal to be find the value of x that makes the left side equal the right side. The problem is on the left we have two terms both involving x, so we need to combine those down to just one term. So if I look at just the coefficients in front of the x's, I have -1/2 and a -1. If I combine those, that will be the number that's in front of x. So let's see, that's -1/2 minus, and 1 is the same thing as 2 over 2. This is really -3 over 2. So I took the -1/2, this -1, I combined it to get -3/2 x. And since I didn't do anything to the right side, that's still just 4. So I took my original equation and I condensed it to -3/2 x is 4. So now what I need to do is cancel the -3/2 that's in front of the x. So the way I'm going to do this is by making an observation. To cancel the 3 in the top, I would have to divide by 3. To cancel the 2 in the bottom, I'd have to put a 2 in the top. And if I want to get rid of this negative, I could either multiply or divide both sides by -1. So there's a nice little trick for this, where let me just focus on the -3/2. If you take the reciprocal, meaning you just flip the fraction and write it as 2 over 3, if you multiply these two things together, the 2's cancel and the 3's cancel. Now there's also this negative, and if you would like that to cancel as well, you can just throw in this extra negative. If you multiply both sides by -2/3, the negative times the negative becomes positive. The 2's cancel, the 3's cancel. This whole thing is just 1. That's telling me the number that I'm going to multiply to both sides of this equation is -2/3. Then I'll just copy down the -3/2 x. And on the right side of my equation, put -2/3. And then I'll write 4 as just 4 over 1. So as we stated, the negative times the negative cancels. The 3 and the 3 both go into each other once, as well as the 2's. So a lot canceled there, which was perfect. You want to choose something that cancels everything. And all that's left over is just a 1 times x. So I'll put x. All right, now on the right side, okay, one of the numbers is negative, the other is positive, so I know the entire answer is going to be negative. There are no common factors that I can cancel, so here I'm stuck multiplying the 2 and the 4, which is 8, and the 3 and the 1, which is 3. So that is 8 over 3. Since I have x all by itself is equal to just some number, this is in fact the solution to the original equation.